Я думаю, все желающие успели подняться на 4-й этаж.
Well, I think that everyone who wanted to attend this presentation are already here. This is the last presentation in today's agenda. So Alexey has downloaded the presentation on the laptop. This is our last presentation for today. In our section, Alexey Lesovsky from Data Aggregate Company. He will tell us about the opportunities of scaling Postgres. Let's welcome him. Good evening, everyone. Actually, I didn't expect to see that many people, and I'm really happy to see all of you. My presentation is devoted to scaling. This is the first slide I would like to tell you about me. I work for Data Aggregate Company as PostgreSQL DBA. We are working with consulting and servicing Postgres. And I used to be a system administrator. And I'm still engaged in system administration, and I really like doing that. So, what is my presentation about? Several years ago, on one conference, I was speaking about top mistakes that are made by developers when working with Postgres, and I showed this slide. It actually shows the opportunities that Postgres provides in terms of scaling when there are not enough resources and not enough power of one node. In that presentation, I said that this picture can actually be described in a whole presentation, and I didn't speak a lot about this slide. And by this conference, I decided to fill this gap. I took this picture and I decided to describe it and describe the opportunities that are present in Postgres to use more power, more resources, and about the way we can scale Postgres. So, I prepared this presentation. It is devoted to scaling use cases. And in this presentation, I will try to summarize the experience that we have accumulated in terms of scaling solutions. The options of scaling that are used by us in our practice for our customers, and to some extent in this presentation. Probably I will not actually share any discoveries with you. I think that most of the issues I will enumerate are already known to you. So this presentation is an attempt to break down this information into sections. And taking into account that it's already 6 o'clock in the evening, I tried not to use some difficult formulas or schemes in these presentations. So this presentation is like a general one. It does not discover any new technologies, any new technological solutions after which you would like to implement something. So, specifically, what will I speak about? I will speak about streaming replication. Who knows streaming replication? Please raise your hands. I need to know it to understand, just to understand the level of details I can go down when speaking about it. I will speak about declarative partitioning. It appeared recently in the 10th release because this is actually a transition zone for us to build more complicated schemes. And I will also touch upon built-in sharding. Actually, my colleagues and I frequently hear this question: how can we horizontally scale Postgres? And this question is quite complicated in my opinion. I tried to answer it. And in this presentation, I will actually share with you my answer to this question. And what I will not speak about. I will not touch upon the issues of planning the scheme and prefactoring scheme for a future sharding. The reason is that, in my opinion, there are no universal solutions, and all these approaches to planning and refactoring of schemes depend on the implementation of scheme and the types of data and tables, so the way the data are placed in this scheme. I will not share with you some success stories about our work with thousands of terabytes for shards, and I will not actually tell you about the way you can use green plum, timescale, citus, and similar things, because you can find it on the web. You can take it from the documents, and actually you can understand the way it can be used. So, when do we think of scaling? As a rule, we have such thoughts when we lack resources. Probably these are processor cores or memory, or we do not have enough space on the disk. So all these system resources that we have in our computers or clouds, or we can think about scaling when our management or business gives us a task to scale for several data centers. So we need to configure the database in such a way that it would live in several data centers, and it would be possible to switch between them in a very fast way if one data center fails. And there are several issues when we do not really need to think of scaling, and I decided to add this slide recently. One of my colleagues, he is on a back row here, he received a mail from another person. This person wrote the following: we have a startup, we are preparing MVP, and in advance I decided to think of sharding in our database so that later potentially we would have fewer problems when we need this sharding. So it was an interesting email, and we answered him that on the stage of MVP projecting, it's not necessary. When a problem appears, it will be solved. So you do not need scaling when all the data fits into your short-term memory, into your RAM memory. And when a project is on the stage of planning, on the stage of launching, you do not have to think about scaling, because actually, as a result, you need to spend additional time on the development, maintenance, and the project becomes more complicated. If you create some Ansible rows, or if you write automation, you need to include some information on the database and scaling, and you spend more time on writing recipes, maintaining them, and testing them. And this is pre-term optimization. So, this is a discutable issue actually, because some people try to plan everything in advance. They want to optimize it for some scenarios of use that they will have in future, but other people think that this is pre-term optimization and it is not necessary. So this is a controversial issue, but I think that pre-term optimization is not necessary because probably we will not need it in the end, but we spend time on it. And when do we need scaling? We need scaling when we have exhausted the resource of query optimization. So you receive reports on the work of your database, and you had already optimized all queries. You built the necessary number of indices. All the indices are used. You rewrote non-optimal queries, so you cannot optimize anything else. All the queries are optimal. But the resources for their processing are not sufficient. When you exhausted the resource of data scheme, you have tables. You eliminated everything unnecessary from these tables. All JSON in JSONB fields are optimized. They are represented in specific columns, or some unnecessary additional fields in these JSONs were eliminated. You do not store garbage in the base, so the scheme was optimized and it stores only necessary information. And you exhausted the infrastructure resources, both hardware, for example, you do not have enough cores, and the use of processors up to 100, or you exhausted the opportunities provided by your software. For example, on every base you have PG Bouncer, it optimizes the number of connections, and still that is not enough. So, speaking about scaling, the easiest and most popular way is to use streaming replication. Who uses streaming replication? I think that everyone does. Streaming replication, it means that there is a master. The master streams transaction logs on replicas. That is simple. And the streaming replication itself is convenient because the nodes, these replicas, can be hard-stacked by nodes. We can switch to them if the master failed, and we can send read-on-read traffic to them. This is an opportunity for scaling. If master cannot cope with the load, then part of read-on-read traffic can be switched to replicas. And in my opinion, this option, well, the option of sending read-on-read traffic to replicas is often underestimated, and it is not frequently used. In many customers, when administering databases, we can see that master is loaded a lot, and replicas are not actually used for queries. And in my opinion, this is a major drawback, because these idle resources, so that they are idle. You're just waiting when master dies and you will switch to replicas. So these resources are idle. That is not optimal. So when speaking about scaling, we should start from replicas. And there are problems here. When we use streaming replication, we can always have problems related to replication lag. The queries that we send to master and replica can give us different results. So, for us to resolve this problem, we should switch to the level of application, and at the side of the application we can understand what data we want to get from the master and the replica. So, in this case, we should connect the application developers and work with them. Another problem is more complex. This is traffic balancing. In this case, we should engage not only the developers but also the infrastructure department. These are admins, or probably some people that support our cloud infrastructure. So we need to have a balancing layer that will balance traffic from application to the base to balance this traffic. Because we have two threads, one thread for the record that should be sent to the master, and a major thread that should be sent to the replica or replicas if there are several of them. And in this case, two approaches can be used for balancing. This is infrastructure-based approach and application-based approach. So, how can they be implemented? Infrastructure-based approach means that we tell our administrators that we need balancing, and they use specific tools to implement the layer of balancing between the application and the base. Here there are various options. If the infrastructure uses DCS Systems Console or etcd, then we can use DNS and DCS systems and build balancing. We can use more popular method, that is the use of separate balancers such as hub proxy, and additional things such as confd, console template, because they define the configuration of the balancer dependent on the changes of Postgres cluster topology. For example, master role is on a different host, and the balancer should somehow record these changes to resend the traffic to the necessary nodes. So additional tools can be used here. And we always need fault tolerance at the level of the network, because we have IP address, we have DNS name that is specified in DCS or application configs, and the application addresses this name to the database through the layer of balancing. So, if IP address belongs to a node, a balancer, and this node disappears, we should have this address available. We should switch it to a different node, and we can do it with Keep Alive or VRRP or similar things that will implement it on hardware or software level. Application-based balancing. In this case, the application developers are in charge, because it is the application that decides the way you will act, the nodes you will use, and the nodes you will take the data from. For example, there can be some relevant data that should always be recent, and we take this data from the master. For example, a very easy example, this is the balance of the user. We always take it from the master, because replication lag should not impede us from getting the recent data. And there are some unimportant issues that can be taken from replicas. And this balancing is at the level of application, but here there are several challenges as well. In our cluster, especially if we use auto failover, the role of master can change. For example, a crash happened, and the role of the master was switched to a different server. Our application should be ready for it, and it should not crash. It should reinstall the connection. It should repeat the transaction, and if it was a query, it should repeat the query. And at the same time, we need to have circuit breaker so that our database will not face a situation when a huge flow of queries come from the application, so you shouldn't spam the base. On the one hand, it looks quite simple, but it is quite difficult to implement all of that in the application, although there are modern trends in the development of applications, and they actually define these conditions. There is a pattern. This is 12-factor application, and these factors include these approaches that the application should implement these operation modes. Where and how do we use it? Well, probably I spoke too much about balancing. Where and how do we use this streamlined replication, streaming replication? In many customers, hot standby is present, but it is not used. And when we speak about allocating resources, we say that part of the traffic can be transferred to replicas. We say that it will be better. We have some read traffic, and we can also transfer analytic queries there. And master will have less load, and we will scale the load that comes from the application. And these replicas are also used for backup. So backup copies are taken from them, they are stored somewhere, so the load is taken from master. This is a bonus of replicas. But as I said, there are drawbacks. The main one is replication lag. And when we use it, we should monitor replication lag for it to be as low as possible. And there are several issues here that can result in replication lag. Some heavy queries, vacuums, especially if there are several of them, some bulk operations on data change, bulk deletes or bulk updates, and there are actually options that help us to mitigate the impact. The impact of these operations. And we should use these operations. For example, if we do bulk updates, we should do it in small batches. If we work with vacuum, we should optimize the configuration of vacuums when a lot of them can work and it will not affect disk performance. And if we use some queries on replicas, sometimes long queries are cancelled and we should be ready for it. This is the conflict of recovery when the execution of this query actually contradicts the recovery of transaction log, and this is a frequent problem. We, in that case, change configuration file.
Also, there is the so-called bloat, when tables and indexes, they blow up when there are long queries, especially when hot standby feedback option is on. It delays the vacuum and cleanup of dead strings on the master and increases this bloat. If we use stream replication, we see pluses and minuses with scale Postgres on the one hand, but there are some issues, some stumbling blocks. We should remember there is no solution which is positive in every respect. Well, we do have a master for record, and scaling of a record is limited by the capacity of one node. I will then tell you what the options are. Reading can be scaled through increasing the number of replicas. Let's look at it from another perspective. When it's not that we have the shortage of resources, but we have the shortage of space for storing data, and all needed data cannot be taken into separate services and can be stored there. In version 10, released in 2018, if I remember well, declarative partitioning was introduced. It used to be done on triggers. It wasn't very handy. You had to write functions for routing. It wasn't easy. Now it is easier. We have declarative partitioning, which is set quite quickly, and the available partitioning on the triggers, it can be easily migrated to declarative. This is a good tool in Postgres, but it is not directly related to scaling. That's why I will not dwell on it too much. The best option of using declarative partitioning is for archive data, which is recorded and read on a regular basis, so we do not change them. So we have hot head data and cold archive, the cold tail, so to speak, that we read on a rare occasion. So when we use declarative partitioning, it makes it easy to control space, because data is separated into sections and we control sections. If we can break it into sections, we can archive those data, download it, place it in a different storage. Moreover, those separate saved partitions in the form of copies through foreign data wrappers can be connected to Postgres, and we can retrieve data from there if necessary. For example, there is a file, foreign data wrapper, which helps connect CSV files in the form of tables into the database. There are S3 foreign data wrapper, an official one, which can help read through C3 and be connected in the form of tables. You can always think of an arrangement, of a scheme, when developers need data, and data must be connected quickly. So we should keep that option in mind, because sometimes it is necessary, it is needed. How do we use it? With one of the customers, we operate a database with 7.6 terabytes. There are a lot of data placed on several table spaces, and it is not always easy to control them, especially when there is shortage of local table spaces. We resolved it. We put all table spaces in one and eliminated that issue. or called archive is called in was stored in S3, we download the unnecessary partitions and put them in S3. The archive takes up only 1 terabyte without indices. And the data have been stored there since 2015. In 2015, we started adding tables. In time, the number of tables grew, so I can't really tell you how many we have at present. What issues do we have? We have implemented it in a simple manner. We did not invent anything. We took simple shell scripts, put them in cron, and by schedule, according to the schedule, those scripts are launched. They pack data, archive data, send them to S3, and the data reside there. This was the straight solution, but it works. Those scripts also delete all data with a simple mechanism that disconnects the old section and deletes it. The main issue is when we have developers and say, connect data for us, data of 2 years ago, 1 year ago, all data. Because this story has been going on since 2015. It has been implemented as SQL backup, as plain text. We now think whether we should use a custom format for copies. We have no ability to connect those sections, partitions, from S3. There are no foreign data wrappers for that, so we have to download it manually, unpack, create DDL, upload it there, and then connect to the main table. This is very time-consuming, cumbersome. When partitioning is not enough. When is it not enough? This question is related to sharding. So we can take declarative partitioning and move those partitions to other servers, and through foreign data wrappers, connect them via VFDV protocol, and they will be seen on the main node. I will speak about this approach, but this is not a very good one, with a lot of drawbacks. This is why, if we do not have an opportunity to improve performance, the easiest way would be the scale-up. We simply add more hardware, increase memory and number of cores. If it's a cloud provider, we take a more powerful instance, which is more expensive. If it is our hardware, we rent more powerful hardware. This option is much simpler as a rule, although it is more expensive. It's better than creating distributed systems on Postgres. Further down the road, there is an option for strong people who like switching and who is ready for challenges. So you can do sharding. You can take unrelated Postgreses on separated services, and one of those nodes can be assumed as a master node and do declarative partitioning, a table based on declarative partitioning, and other sections should be placed on other nodes, and through foreign data wrappers you can connect those tables to the master node. So the application, as it works with the master node, it will operate with our page nodes and take data from there. But in reality, the application will think that it operates only with one node. Is there any other option? I don't think so. The Postgres does not offer any other opportunities. This is the only one. But there are issues. This is not an ideal approach, but I don't see any other options, because there are no tools to implement other schemas. We can take separate products like Greenplant, PostgreSQL, Citus. They do have their own drawbacks, but give the user additional functionality in terms of horizontal scaling. Both those options and the solution that I've just described, they have the same issues. For instance, high availability drawbacks. All page nodes must be supported by replicas, because if the node is out of order, we lose data, and we need a replica in order not to lose those data. Not the best performance is another issue. If we take, let's take PostgreSQL CitusDB two-phase commit. This is not a fast one. If there is a slow network, data exchange and coordination among all stakeholders of the quorum, participants of the quorum, all this will take time. It will be slow. If we take the option with declarative partitioning and foreign data wrappers, there will be no two-phase commit there. And we can directly write into page nodes. We can write data into them, but we should keep track of the data being coordinated. This is quite a challenge, so before you do it, think twice. And performance is an issue. I used to do a benchmark. I just took some dumb nodes with 2 cores, 2 gigabytes of memory, and I did some benchmarking. I compared this arrangement with declarative partitioning and foreign data wrappers. I took a small data set that could fit the memory to mitigate reading from the disk, not to include disk reading into the performance. And I tried to see how it worked. The table was simple, made of 3 fields, timestamp and 2. So the queries were simple. First is select by the first key, by the primary key. Baseline. These are cases as if they lived on one host. In the second case, it is sharding, as if the data were placed on page nodes and we would be working with a master node. The difference in the time of queries is 6 times. Well, it's about milliseconds, 0.5 milliseconds, and in the second case, it was 2.9 milliseconds. From the unloaded perspective, it is possible, but those milliseconds may play a big role in some cases. Let's take several strings. So in this query, we take 1,000 strings. Time goes up from 2 milliseconds to 26 milliseconds. So the difference is 9 times. Then let's calculate the aggregate for those data. Time has remained pretty much the same. It used to be 26 milliseconds, now it is 24. Pretty much the same. And the final option is the update. We do update on the primary key, and the difference was 5 times as with the first query. So we can see that this solution with declarative partitioning and foreign data wrappers, it is not the fastest one. But I later thought that it would be better to do a test when page nodes were on one node. Here we face the network performance, but it would be great not to account for the network performance and see how it operates on one node, to see the overhead of the Postgres itself. But I got this idea quite late, so I didn't do it actually, I didn't test it this way. What are other options? There is PostgreSQL with two-phase commit, as I said. It is slow. There are also transaction manager GT nodes which coordinate the flow of transactions generated by the system, which causes further delays in processing a transaction. Also, we have issues with high availability. Each node should be supported by replica to avoid loss of data in case of a shutdown or a crash. There could be other solutions on the SQL database, Cassandra, React, but they are optimized for recording. We can record a lot of data in it, but this is not a full-fledged SQL solution. We do not have the SQL language. We cannot do joins, and there are other drawbacks related to those solutions and systems. A small summary. I hope you understand that Postgres is limited in terms of scaling. We can easily scale chaining, but as far as reading is concerned, it is not easy. We have streaming replication, and we can create a lot of replicas and direct reading there. But as far as recording is concerned, we are limited with the capacity of one node. We can think of other solutions, but those solutions will be for a fee. They will not be free, and they will also have their pros and cons. That's all I have for today. And before you ask questions, let me advertise a small conference to be held in St. Petersburg on July the 20th, PG Day. It's a very good conference. For 2 years we did not have it, so those who live in St. Petersburg, or for those who it is easier to travel to St. Petersburg. So you are very welcome. Myself and my colleagues will make presentations, not as boring as this one, hopefully. We'll see. So it will be 6 months from now. So thank you. Thank you for your presentation. So you mentioned host and buy, and 13.5 item of Postgres manual, a warning: host and buy does not support all levels of isolation. For instance, the master does repeatable read if it is serialized. Then there might be some nuances on the replica. It was only a comment. Yes, indeed. There are some nuances. Serializable, these are rare cases. It is not all. It is needed on a very rare occasion. I have 2 questions. When sharding, when you have the master base that can go to other bases. So the question is, there might be a lot of data. Data might be different. It might change within one transaction. So in this case, how will this transaction take place? If it is about the master database, it will work as with regular Postgres. So there'll be all appropriate blockages as when we work with a transaction, and there will be limitations imposed by the foreign data wrapper. So check the documentation to understand how it operates in difficult cases in the transactional mode. So in other words, if data changes in the master base and in some of the shards, how it's going to be coordinated. So we can use sharding, and in case of sharding, there'll be record in the local data in some local table, and we will have a recording in the partitioning table. And then the query will go to the foreign data wrapper to the page table, and changes will be made. As to Postgres, from the Postgres perspective, the operation will be the same. There will be some nuances with the foreign data wrapper operation. But from the application point of view, no changes will be needed. For the application, this is the master table, and the sharding will not be noticeable, and it will be transparent. Thank you. Thank you for your report. A question on the PPL proxy. Why did you mention this? PL proxy is a complex thing with a very steep learning curve. If you really want to use it, you can do it. But a young gentleman came up to me asking, he asked about Pgq documentation. Very little documentation is available. So my answer would be yes, you can do it, but we haven't done it with any of our customers. But indeed, we can use SQL proxy and build proxy sharding on QL proxy procedures. Thank you. You mentioned replica on shard. PVD table is looking into the master base, and from this master base we have a replica, and at this point, yes, all queries are suspended at this point. So yes, there's only one solution. We replace DNS. So the sharded replica. Yes, this is an additional difficulty. As I said, this solution is only for strong people. It is not easy to understand how to handle it in the beginning.
Well, yes, there are some options here. You can stream it, but I think that this mechanism ignores actually your attempts of deleting it, and well, I do not have a solution. Using debugging tool, well, that's a good way. I have an addition regarding FDW. So I can comment on the following case. The user of the debugger is the user of the database, and the roles regarding queries, samplings, updates, inserts, deletes are arranged not only at the level of the application but also at the level of the database, inside the database. So these are the stored procedures, not the stored procedures, but specific tables for fulfilling specific functions, specific views, all of that. So the rights are described in the DBMS, in the tables, in the system tables. So here is the question. Well, yes, it is possible, but these are additional costs for maintaining and implementing. But you know, I've just thought about it. Quite possible that we can give statement timeouts, log timeouts for queries, so that if this replica fails, these queries will be cancelled when timeout is due. And how can we substitute the replica? Look here, our task is to kill the activity and do maintenance after that. For example, we short the activity by timeout. We were lucky enough and we shorted, and at this moment we make alter for user mapping and server mapping. Probably yes, because this is DDL. Well, yes. It's difficult to make up something at once. Probably we can set some maintenance to the application. We can inform the application that we are degrading, and part of the data that were shared, that were sharded, cannot be used right now. The application can see that we should degrade smoothly, and that's okay. It returns some error to the user, for example, repeat this query later, and during this time we do maintenance automatically. But you know, these are like crutches. Yes, indeed. So, this is a way for the strong ones, because quite frequently, well, we don't know what will happen in the end. Thanks a lot. Okay. Thanks a lot for your presentation. I'm wondering, what is the size of tables that you connected? Terabytes of tables with billion lines, for example. Did you have them? And what kind of bags did you have? Maybe you had some difficulties. Well, we didn't have terabyte tables. Normally, the table size was within the range, I don't know, from thousands of gigabytes, apart from indices, probably 90 or 100, but we didn't have 1 terabyte tables, because in that case, backup will be continuous task, a permanent task. That's why our partitioning, well, the size of tables is not that large. Thank you for your presentation. It was really interesting. It was a long way. And, as a life hack, I would like to say that we actually had the similar way, and the issue of flags was resolved when we used Infinet. As I remember, it is like 40 gigabit. Yes, this is a good solution, but it is expensive. Okay, other questions? Oh, I'm Alexey's colleague, and I would like to add another option of native partitioning with inbuilt tools of Postgres, when you can get multi-master that uses the features of logical replication. If you have some reference data that should be present on all the nodes, and you can somehow allocate this data on the nodes, you can raise many masters of Postgres, and the reference data through logical replication and the mechanism of table publication at subscription will be disseminated to all nodes. But now I do not recommend to play with it, because recently we actually, we heard of many problems related to logical replication. It has a lot of bugs when master server that publishes the data dies. But just an example, when all the bugs are corrected, the native tools of Postgres can be sharded separately, but you need to understand that this application should be able to work, and it should understand that you have a lot of different masters without foreign data wrapper. And foreign data wrapper is an instrument when you have one point master server and you don't really care where the query goes after that, and in this case you will have to care about that, but you can write it the way you want and where you want. This is a brief addition. Thank you. You can take version 11. Thank you. Thank you for your presentation. It was very interesting. We have many things to think about. Let's thank our speaker. Thank you.